Hello, my dear students. Welcome you all to Sri Jain Rank Zone classes. I am your mentor and your friend for the subject chemistry, and I will be taking the organic chemistry. My dear students, in the previous video, we discussed about different types of plastics. We discussed about polyolefins. We discussed about polyhaloolefins, which includes polytetrafluoroethylene, polymonochloro-trifluoroethylene. Today, adding one more polymer to that topic, that is PVC. PVC, also known as polyvinyl chloride, the monomeric unit is vinyl chloride. It is a homopolymer and it is a chain growth polymer. It is thermoplastic, uses when added with some plasticized with esters, high boiling esters. It can be used to make raincoats, handbags, shower curtains, fabrics, shoe soles, vinyl flooring. It also acts as a good electrical insulator and also used to make hose pipes. Hose pipes. So these are the uses of polyvinyl chloride, which is the polymer of vinyl chloride. It is a homopolymer, it is a chain growth polymer, it is a thermoplastic. When it is added with high boiling esters, it can be used to make raincoats, handbags, shower curtains, fabric, shoe soles, vinyl flooring. It is a good electrical insulator and it is also used to make hose pipes. Okay. Now, now we are going to discuss about formaldehyde resins. It includes polymers like this category. It includes polymers like bakelite and melamine. Okay. The first is phenol formaldehyde resin, also known as bakelite. Okay. This is phenol. This is formaldehyde. Base catalyzed or acid catalyzed reaction to form orthohydroxybenzyl alcohol plus para-hydroxybenzyl alcohol. Okay. The condensation of orthohydroxy or para-hydroxybenzyl alcohol gives a linear polymer. Hydroxybenzyl alcohol gives a linear polymer. Okay, like this. Undergoes polymerization. So condensation polymerization. Methylene bridges. OH. OH. This linear polymer is known as what? Novolac. Novolac. Okay. Now, if ortho and para both are used, it gives a cross-linked polymer known as bakelite. So it is a copolymer. It is a copolymer and it follows step growth polymerization. It is a thermosetting polymer which is hard and brittle. In units. They undergo polymerization. Again, a condensation polymer. like this. Okay. Uses. With low degree polymerization in soft bakelite is used as binding glue, okay, for wood varnishes. If high degree polymerization, to make mica plates, mica tabletops, fountain pen barrels, electrical switches and plugs, etc. Okay. So this is the formation of bakelite. Previously, we have seen that formation of novolac. It is a thermosetting polymer. It is hard and brittle. It is a copolymer. It follows step growth polymerization technique. Okay. The low degree of polymerization, if it is taken for formation of bakelite, then it is used as a binding material, adhesive material for wood varnishes and lacquers. High degree polymerization is used to make mica tabletops, fountain pen barrels, and electrical switches. Okay. Now, moving to next, melamine formaldehyde resin. Formaldehyde. You have to differentiate novolac and bakelite. At one is the linear polymer and the other one is the cross-linked polymer. Okay. Melamine formaldehyde resin. It is also formed by condensation polymerization. So it is a condensation polymer. Copolymer. Okay. This is melamine. It combines with formaldehyde, forms an intermediate first. It undergoes polymerization. formaldehyde relation. It follows step growth polymerization. It's a thermosetting plastic, thermosetting polymer. It is hard but unbreakable. To make non-breakable crockery. Okay. Then comes other category after the formaldehyde resins, that is polyacrylate. It includes polymethyl acrylate, lucite, acrylite, and plexiglass. And perspex. These are the some common names like lucite, acrylite, plexiglass, and perspex. The monomeric unit is okay. It is a copolymer. It is hard, transparent, the optical clarity is very high, even better than ordinary glass. Okay. It is used to make signboards, transparent, domes, aircraft windows, dentures, and plastic jewelry. So this is polyacrylate or polymethyl methacrylate. Okay. Then there is another acrylate polymer is polyethyl acrylate. Okay. Now polyethyl acrylate. Under polyamides, we discussed nylon 66, we discussed nylon 6 or Perlon. There is other compound nylon 610. The monomeric unit is hexamethylene diamine, and sebacic acid. It is a copolymer, linear, formed by step growth polymerization technique. It is a thermoplastic, having high tensile strength, and it is abrasion resistant. Used to make textile fabrics, carpets, bristles for brushes. Also used as a substitute for metals. Also used as gears in hosieries. Okay. The another one copolymer, dinyl, copolymer of acrylonitrile, 40%, and vinyl chloride, 60%. It is used to make hair wigs, artificial hair wigs. Artificial silk is prepared from cellulose. Okay, it is prepared by viscose process. Okay, the difference between natural and artificial silk is natural silk basically contains nitrogen, while artificial silk may not have nitrogen. Okay, the natural silk on burning gives a smell of burning hair and shrinks into a ball of cinder, while artificial silk gives a thread of ash. Artificial silk basically made up of cellulose and the cellulose products. Now I am going to discuss about estimation of molecular masses. Okay, polymers other than biopolymers like protein, starch. Okay, so all synthetic polymers, I should say. Okay, polymers other than biopolymers, that is synthetic polymers or semi-synthetic polymers, they mainly contain monomeric chains of different length. That is why average molecular masses is calculated. While in case of natural polymers, the molecular mass is definite because they contain chains of identical length. Now, the molecular mass of the polymer, it can be expressed in two ways. First is by means of number, average of number, okay, which include basically number of number average molecular masses denoted by ml. Okay, it says what? Suppose if n1, n2, n3 dash dash are the number of molecules with molecular masses m1, m2, m3, m1, m2, m3, okay, then the number average molecular mass can be written as n1 m1 plus n2 m2 plus n3 m3 plus n1 plus n2 plus n3. Okay, it can be written as sigma n1 m1 upon sigma ni, okay, or sigma ni mi. Okay, ni is basically the number of molecules of the ith type. Okay, n type, ith type. Okay, it cannot be defined actually. Okay, then comes the weight average molecular mass. Okay, it says what if m1, m2, m3 are the masses of monomeric species with molecular masses the small m is the given mass, okay, with molecular masses m1, m2, m3, then the average molecular mass can be given as w m1 m1 plus m2 m2 plus m3 m3 upon. So basically in both of the types what we have done, the first we have calculated the average by number, and secondly we have calculated the average for molecular mass only. But first we are calculating the average by number, second by average by mass. Okay, it can be written as sigma mi upon sigma. Okay, the given weight can be related to the molecular weight by multiplying it with the number of molecules, that is Avogadro number in simple saying. It can be written as okay. Now there is a term polydisparity index. Polydispersity index. Polydispersity index. It is a ratio of MW, that is mass average molecular mass, and MN, number average molecular mass. Okay, it is denoted as PDI, which is equivalent to ratio of mass average molecular mass, number average molecular mass. Okay, based on the polydispersity index, we have monodispersed polymers, for which the mass average molecular mass and number average molecular mass remains same. Okay, if the PDI is 1. Then polydisperse, it simply means that they have wide range of molecular masses, mean molecules having wide range of molecular masses. So for this, MW is greater than MN and PDI is greater than 1. Okay. Natural polymers are more homogeneous than synthetic polymers. Than synthetic polymers. So for natural polymers, the PDI is always unity, and it means they are monodisperse. Okay. For synthetic polymers, the PDI is greater than 1 and therefore they are polydisperse. The property is used to calculate the, for example, osmotic pressure, which is a colligative property depending upon the number of moles. So this mass helps to basically calculate the osmotic pressure, and that is why osmotic pressure is the best way out to actually calculate the molecular masses of macromolecules, okay, like biological polymers. Okay. Now the last topic is biodegradable polymers. Synthetic polymers, they don't undergo the natural process of biodegradation by microbes like bacteria, fungi. Okay. So biodegradable polymers, they are eco-friendly. Okay, they are the polymers which can be degraded by, they can be degraded by, or I should write, they undergo The natural process of microbial breakdown, they do not affect the food chain. They undergo the natural process of microbial breakdown, okay, within suitable time. Okay, so they are biocompatible, eco-friendly, don't need special waste waste disposable method. Other than this, they do not affect the food chain and they are not harmful. Okay. So in biological system, the biopolymers they all are like protein, starch, almost either up to the range of 100% or approximately equal to 100%, they can degrade themselves. Okay, if they are not degrading completely, then their degraded products, partially degraded products, they are not going to harm the environment. So protein, starch, okay, they all are fats as well. Okay, they undergo enzymatic breakdown by microbes. Okay, some common examples are PHBV, that is polyhydroxy poly beta hydroxy butyrate, copolymer with beta hydroxy valerate. So it is a biodegradable polymer. It is a copolymer of 3 hydroxy butanoic acid and 3 hydroxy pentanoic acid. Okay, they are joined through ester linkages. So it is a copolymer, it is a biodegradable polymer, okay, known as PHBV polyhydroxy valerate, copolymer with polyhydroxy butyrate. Okay, the properties of PHBV, it depends upon the ratio of both of these polymers. That is, if 3-hydroxybutanoic acid provides stiffness, ratio of both monomeric units decides the properties. Like 3-hydroxybutanoic acid provides stiffness, while 3-hydroxypentanoic acid provides flexibility. It is used to make packaging materials, orthopedic devices, and also used to make capsules, okay, for the controlled release of drugs. Capsules covers or instruments for controlled release of drugs. Okay. Then comes polyglycolic acid, PGA. It is a chain growth polymer, okay, which is a dimer of glycolic acid. It is alpha hydroxy acid. Polyglycolic acid. Then polylactic acid. All naturally occurring alpha hydroxy acids are biodegradable. Okay. Polylactic acid, PLA. It is basically a cyclic dimer of lactic acid. Lactic acid is it is also alpha hydroxy acid. This is the alpha carbon having OH group. Undergo condensation polymerization. Which will help to bind these two ends, okay, together, making a cyclic appearance. Okay. Then caprolactone, poly PCl. It is also a chain growth polymer of 6-hydroxyhexanoic acid. Okay. And the last is nylon 2 nylon 6. It is a polyamide polymer, copolymer of glycine and aminocaproic acid. Glycine is the simplest amino acid. This is aminocaproic acid. Okay. So this is about the biodegradable polymers. My dear students, we have completed the chapter polymers. If you're having any problem, you can post your problems, you can share your problems anytime. Please take care, stay safe, stay healthy. Bye bye, take care.